Oh. So I'm Vivi Suhendra, the Executive Director of the Singapore Cybersecurity Consortium. So I'll be managing the flow of this event. As I've mentioned, this is our annual event where we launch our SIGGRAM call. And of course, on this occasion also, we have invited some speakers to share their knowledge on the theme of cybersecurity and innovation. So I hope you will enjoy today's program. So without further ado, I will invite our academic director, Professor Abik Roy Chaudhuri of NUS, to give welcome remarks. Prof. Abik, please.
Okay. Thanks, Vivi. I'll just share the screen. Okay, so I hope you can see it now.
Yes, I can see
Sorry.
yeah. It's on presentation mode now, yeah. Oh.
Okay, thank you very much, Vivi. So it's really my great pleasure to welcome you all to this virtual Wild and Crazy Ideas Day, which we are organizing virtually this year for the Singapore Cybersecurity Consortium. Okay. So I'll just give very brief remarks before the event can proceed. I'm Abhik Roy Chaudhuri. I'm serving as the academic director and the principal investigator. And so I'll just give very brief remarks of the Cybersecurity Consortium and exactly the values that it embodies. So this is a nationwide platform for engagement. So the main sort of value that it embodies is that it allows for engagement between industry, academia, and government. So oftentimes we may be having two of these three parties, but not all the three parties. So in this case, all of the three is the tripartite partnership between the industry, academia, and government. This is allowed for in this platform, leading to greater awareness, adoption, as well as translation. And this is supported by the NCR program, which has existed for a number of years now, the National Cybersecurity R&D program, and it is anchored at the National University of Singapore. Okay. So as was mentioned, this is really allows for a partnership between agencies, industry, and academia, and this is not only as a desire, but also really it is implemented inside many of the instruments that we administer via this platform. So between the Singapore public agencies, the industry members, and the institutes of higher learning. So the main focus in this consortium, since this is an industry consortium, is of course on the industry members. So these are all of the members we have at this point, and we very much thank them for their time and engagement. And on top of that, the various public agencies, specifically the public agencies under the National Cybersecurity Research Program, the NCR program, are involved in it, as highlighted here, as well as the various institutes of higher learning. So definitely all of the universities and institutes that are highlighted over here. So in the NCR program has a number of instruments which allows for greater engagement. These include the National Satellites of Excellence. So one of the National Satellites of Excellence, the one on trustworthy software systems, is in fact at NUS. Then at SMU, there's the one on mobile systems. In SUTD, there is one on critical infrastructure and so on. So there are the various National Satellites of Excellence. There are local and international research grants, as we're aware. There's the National Cybersecurity R&D Laboratory, as well as the iTrust Labs, which essentially provides certain platforms, like certain implementation platforms. There's the Singapore Cybersecurity Consortium, and this is specifically the event, the instrument we are in. And there is also the Cybersecurity Postgrad Scholarship. So the Singapore Cybersecurity Consortium is really nestled inside the National Cybersecurity Research and Development Program, or the NCR program. And so this is really a big picture kind of slide. In terms of governance, we have a steering com, which is chaired by Professor Chen Suhan, who is the Deputy President of Research and Technology, and also a management committee, which has representatives from all of the universities. There's NUS, NTU, SMU, SUTD, and so on. So what we do, so there are really three pillars. As I mentioned earlier, we are interested in awareness, adoption, and translation. So accordingly, there are three pillars through which we kind of deliver the various activities. The first pillar is the training and technology update. So this is more on the awareness side. Then we have discussions to alleviate the pain points in the existing work. So this is going a little bit deeper, that is the adoption. And finally, there's the process of translation, dreaming up of newer technologies, under which we give the seed grant call, and that is the part that Vivi mentioned earlier. So I'll discuss a little bit about each of these activities. So under the training and technology update, we have this annual cybersecurity camp, which has always been held from the very inception of this effort. And we also hold the quarterly technology talks. I'm in fact very pleased that even in the middle of this pandemic, the pandemic has been dragging on for quite some time now, but we only stopped for a short period when it first happened. But since then, we have been continuing with all of these efforts, including the technology talks and also the small group meetings. So we really haven't stopped engaging, which is, I think, a very, very positive sign. In terms of the adoption, since usually this involves some discussions about, in particular, informal discussions, where people are really comfortable on discussing some of the organizational challenges they might be facing in terms of cybersecurity enhancement and its adoption. So therefore, we have strategically formed the special interest groups so that people are comfortable to discuss some of the problems and share ideas. And also we have this annual Wild and Crazy Ideas Day, which allow for pitches. And we are very pleased to see that there will be a number of pitches today as well. And finally, in terms of the translation, we have the seed grant call also, which we have been administering from the beginning. So just very briefly on each of these, the annual cybersecurity camp, as mentioned, this has been held from the very beginning since the inception of the consortium. We started in 2017, which was actually the camp for 2016 because the consortium was formed in September 2016. So just early 2017, we had the camp for 2016. And since then, we have always been having one camp per year, except for this year in 2019, where we had an additional camp as part of the RSA conference. But towards the end of the year, we have always been having one camp. This could be on very topical things like deep learning and cybersecurity or blockchain and cybersecurity. There was one on secure critical infrastructure and so on. So last year we held it virtually and we will of course continue with this camp. This provides a good opportunity for not just knowledge dissemination, but also some hands-on learning. The technology talks have always been there. These are held quarterly. We have had government speakers, student speakers, international experts, as well as definitely industry speakers, a lot of industry speakers in these quarterly technology talks. The special interest groups, this is something we mentioned. This is a little bit of an innovation on our front. So oftentimes people hold the special interest groups based on sectoral areas, that is sectors of the economy, like on telecommunication, they have a special interest groups and so on. What we have done in our case is that the special interest groups are on technical areas, but instead of only discussing just the technical research, in that technical area, what are all the various companies, what are the challenges that they are facing, what are some of the upcoming trends. We try to have small group discussions on that. So this is a little bit, so just to elaborate a little bit, this is the little bit of the innovation or the thinking of on our front. Instead of just forming it based on the sectors of the economy, we still have it on technical areas, but within that technical area, what are the technological disruptions that are happening? This is something we try to bring into the discussions. So the special interest groups also, we want all of the institutions of higher learning, as well as other partners to have engagement. So each special interest group is actually headed by a partner. So there's one from NUS on threat intelligence. We also have this one from MHA, from Ministry of Home Affairs on cybercrime, and so on, and from the various universities, NTU, SUTD, and SMU, as well as ASTA. The Wild and Crazy Ideas Day is today, so I'm really excited and looking forward to the discussions. We have problem statements usually from agencies. The researchers could try to pitch their ideas, as well as industry professionals and researchers. They could also pitch certain things where they would want the academia to contribute to, because they also would want greater participation from the academia in solving some of their problems. So I do see some of our members here on this slide. Then the seed grant call. In fact, the Wild and Crazy Ideas Day usually feeds into the seed grant call. This is the way it is structured. The seed grant call, again, this is a little bit of an innovation on our front, the way we have structured this instrument, the Cybersecurity Consortium, from the beginning. Instead of giving the grants to the companies, or even giving the grants to academia, it is always given to a company academia pair. And later on, we further allowed the academia and public agency pair, of course, the public agencies in this case being self-funded. Okay. And usually, since this is more on translation, we are looking for targets which are of higher technology readiness levels, or higher TRL. We have completed, since the consortium has been around for about 5 years now, we have completed, rather our members have completed, it's not that we individually have completed, but our members as a whole have completed number of projects which have subsequently been taken forward. For example, this one was between ADSC and Nova Systems, and where the findings have been subsequently shared with CAAS, the Civil Aviation Authority of Singapore, and applied in the company. There are a number of other projects that have been done. This was between Custodio and SUTD. And there's one, this one is between PayPal and NTU. Sometimes we also make, these need not always be a direct translation inside a company. It can also lead to a certain artifact, like a database of malware in a certain context, which is then subsequently made available to the Singapore community, because we want to serve the Singapore cybersecurity community, to make available to the entire Singapore community. So this is also another way we are trying to help the community, apart from translation, the direct translation, also making certain artifacts available, which can enable translation of other technologies. Like if you have a good database of malware, presumably if you have a malware identification tool, you can try it out on that good database. So those are also other certain other instruments through which we are trying to help the community. There are the seed grant projects that are ongoing. All the partners are highlighted here, so I'll probably not talk that much about them. Of course, congratulations to all of these colleagues on securing these projects, and we look forward to their continued engagement, participation, and contributions. On top of these 3 pillars, so this pretty much completes the 3 pillars that was mentioned: the training and tech update, the adoption, and the translation. On top of these 3 pillars, we also try to help out in various instruments to enable the tech adoption drive. So in particular, we hold this Industry Day, and we have also participated in the Cybersecurity Innovation Day, which is actually organized by CSA. And similar other instruments. We participate in these events and try to further push the tech adoption drive, so that specifically for the companies and the organizations in Singapore, the state of practice, what we call as the state of practice in cybersecurity, this is enhanced. So this is something we are truly invested in. We want to move the needle in terms of the state of practice. And all of this is really with this goal. So with this, I think I'm finished with the remarks that we wish to make. If there are any companies who are not members of our consortium, hopefully they can consider becoming a member. We do have a number of benefits for them. They can have a close relationship with the local research community. Of course, they can reach out to researchers individually, but through the consortium, they can glide into those relationships more easily. They can have access to talent. Also, they will only be eligible to apply for the seed grant if they are members of the consortium. And I guess Vivi will talk about the seed grant later on. So if anybody is interested, feel free to email at this address. This is highlighted on the slide. Cyber, it's very easy to remember, cyber@comp.nus.edu.sg. So if anybody is interested, please just send an email, a very short one, and then subsequently the procedure will be triggered from there. And if there are individuals that are interested, individuals directly do not become like members. The membership is only for organizations, in particular companies. But individuals can certainly join the mailing list so that they receive the invitation to the various activities, such as the one that we are currently in. And you can, of course, look up more about our activities from this website, which is https sgcsc for Singapore Cybersecurity Consortium.sg. Okay, thank you very much. And I look forward to a very pleasant and very exciting engagement today. Once again, these are all of our contacts, our website, our email contact, and our Facebook presence. Thank you very much. And with that, I would give back the floor to Vivi.
Thank you very much, Prof. Abik, for the introduction and the welcome address. So on our agenda next, we have our research talk, which will be delivered by Assistant Professor Jialin Lee. So I will invite him soon, and I would like to introduce him. So he is an assistant professor in the School of Computing at the National University of Singapore. So before joining NUS, Jialin received his PhD from the University of Washington in 2019 and his bachelor's degree from the University of Michigan in 2012. So his current research interests are in the systems design for reconfigurable hardware and co-designing distributed systems with data center networks. His research has been recognized with Best Paper Awards at NSDI and OSDI. So today, Jialin will speak to us about scaling network security using in-network computation. So I will pass the floor to Jialin now. Please feel free to share your screen.
Thank you, Vivi. Let me share my screen. All right, yeah, can you see my screen?
Yes, I can see.
Yes.
Yeah.
Okay, great. Should I start?
Yes, please.
Okay, cool. All right, thank you. Hi, everybody. Today I'm very excited and privileged to be invited to give a talk. Today I'm going to talk about some of the recent work our group has done to try to scale network security systems using in-network computation. The networking industry has been pretty relentless in terms of getting higher and higher, increasing in network speed. So you can see, for example, just the Ethernet standard. Just a few years ago, right, we are still mostly using gigabit or 10 gigabit Ethernet. But in the recent decade, we are seeing more and more deployment of 100 gigabit or even 400 gigabit Ethernet in things like data centers. And these large data centers are becoming more and more commonplace today. And they're this gigantic scale. And in terms of just network speed in them, there's a increasing amount of network speed and traffic in these data centers. And we are also have other kind of networks, like in terms of wireless network and 5G networks, right? So we're also witnessing a large increase in their speed and the resulting increase in the amount of traffic. So at the same time, so because there are more and more infrastructures moved to online, and because the more valuable user data and even monetary assets are being moved onto the internet, we are also witnessing more and more network security attacks, cyber attacks these days. And because of these valuable assets and user information. So a lot of the applications, the users and these companies are putting more and more emphasis on the security aspects of their system deployment. So traditionally, how do we actually deploy these security systems? So in general, there are like two ways. One way is, for example, in your enterprise or data center network, you may have some of these intrusion detection systems, your scribing services, being deployed on these powerful servers running either on-premise or off-premise or in a cloud, running systems like Suricata, Zeek, or Snort. So the other way is for you to deploy some of these specialized systems, specialized hardware called middle boxes that implement firewall, your phishing detection, your deep packet inspection, and you deploy them inside your network as these physical appliances. So another interesting trend in the computing world is the end of Moore's law. So, Moore's law has been really fueling the semiconductor industry for the past 30, 50 to 50 years. Right? So the Moore's law basically says that the number of transistors on a particular integrated circuit doubles about every 18 months, so about 2 years. Right? So if you combine Moore's law with Dennard scaling, so what you usually get is you have almost free performance frequency improvement and faster speed in your general purpose processors every 2 years. Right? So this trend has been holding up pretty nicely before 2000. But right around that time, in the past 1 or 2 decades, because of the physical properties of semiconductors, we are really seeing a slowdown of Moore's law and basically a stop of Dennard scaling. So what that really means is that your general purpose processors are not really getting any faster, especially in terms of frequency. Right? So Moore's law has been still been going on. So we have been packing more and more transistors, and like in terms of like when you add more processors, more processor cores, your multi-core CPUs, but the frequency really stopped there. Right? So we are not really seeing a lot faster in the single-threaded performance. Right? So what does it have to do with network security? Right? So remember when I in the first slide when I introduced the introduction. And so we are still having a faster and faster network, and that trend doesn't seem to be slowing down anytime soon. So what that really means is that to provide the same level of network security when you deploy these network security solutions, you need to increase the amount of hardware to handle this network traffic and network speed, right? So that means you need to increase the hardware cost dealing with this, right? That's number one. So number two, because we are not getting the processors are not getting any faster. Right? So that means with more and more traffic pumping through these network security systems, then we are unable to provide real-time and fast detection and mitigation of attacks. Right? So these are really the two of the big challenges the network security are facing moving forward. So the big question I want to answer in this talk, or at least try to motivate, is there a way we can scale network security solutions to keep up with increasing network traffic and speed, despite that we are basically having no more faster general purpose processors? And so for that, we are, at least our group is looking at some of the recent advances in the networking hardware. So specifically, we're looking at, there's a trend in the networking hardware community where we're building more and more programmable network hardware. So these things include programmable reconfigurable switches and smart network interface cards. So switches and network interface cards, or NICs, traditionally they are fixed function devices. So they provide just fixed, they can process a fixed set of network protocols. Right? For example, your IP, your Ethernet, your TCP, your UDP traffic. Right? And after they are manufactured, after they're installed, you cannot alter their behavior. Right? So they just sit there and process the actual traffic that they are initially designed for. Right? However, recently there is this trend that putting programmability into this hardware, so that even after manufacture, after you receive the physical devices, you can program these devices to do different things based on user and application needs. So let's look at one of these devices, which is the focus of today's talk, is programmable switches. Right? So compared to their fixed function counterparts, right? So what are new in these programmable switches? Right? So these switches really offer a few different functionalities that can really change this the way we actually use these switches in the network. So for example, these devices enable programmable packet header parser. That means developers can define their own headers. Right? They no longer be restricted to the headers already defined, for example, IP and TCP. They can define their own application level headers. And secondly, the processing pipeline in these switches are also reconfigurable. Right? So you can design your own processing pipeline, your own programmable logic, your own logic, defining how you process these packets. Right? So these will include things like you can do simple arithmetic on the packets. You can also rewrite packet headers and define if you want to do multicast, broadcast, or unicast of these packets. And also, these devices contains this general purpose stateful memory to maintain state across different packets. So combine all of these, what it really enables is you can do some application specific computation on these devices. And the really nice thing is that you can do them at the line rate of the switch, meaning that you can do these computations at terabits per second, and they can even provide like billion packet processing per second. And this technology, the nice thing is that they can scale with the different generations, right? So the current generation, we have maybe 1 terabit per second switches, and later when we move on to 10 terabit switches, these application specific computation can also scale. Well, so with these newer programmable network devices, so is it possible that we can build scalable and network security solutions that happens inside the network? Right? So we don't need to redirect this traffic somewhere else, for example, like scrubber services, and we can process them directly on these programmable network devices. So in this talk, I will briefly talk about 2 of the more recent work we have done. So the first one is called DSketch, where we do an accurate heavy hitter detection on these commodity programmable switches. And secondly, I'll talk about DITA, our in-network defense architecture against amplified reflection DDoS attacks. So first, I'll talk about Sketch, which is our new heavy hitter detections using programmable switches. So in your enterprise network or in the internet, in your data center network, so there are many concurrent flows going on at any point in the network. Right? But these flows usually follow some kind of distribution, right? Meaning that there are a small number of flows that account for majority of traffic. And we call these big flows either elephant flows or heavy hitters. And so to identify heavy hitters, pretty easy, right? You just keep track of each flow count and look at which flow has the most flows in the past like few seconds, for example. So being able to detect these heavy hitters or elephant flows is critical to a lot of the network security solutions. So for example, these are widely applicable to network load balancing, DDoS detection, congestion control, anomaly detection, and so on. Right? So for example, it's really critical for you to identify these heavy flows so that you can so those are mostly a target for when you do load balancing in the network, or those are the target when you try to identify if those are really the DDoS attacks happening. So traditionally, how do we do heavy hitter detection in a network? So what we do is we mirror this traffic to some remote controllers, right, for monitoring. Right? And then these controllers will keep track of the flow counts and sort them and pick the ones which has the highest flow, the number of packets. However, forward every single packet in the network to controllers is impractical, right? Because you have hundreds of gigabits to terabits of traffic, and to just pump them into some remote controller is just not feasible. So what people usually do is they take a sampling approach, right? So they do sample a few packets and forward them to the controller. So this approach works fine. So reduce the amount of control plane traffic to the controllers. But there are, of course, a lot of issues with this because it's sampling. So naturally, we're not able to obtain fine-grained metrics. And there are a lot of this valuable information that is being thrown away because of these packets not being sampled. And then another problem is that it will result in low accuracy. So it's very easy for you to miss a lot of the real heavy hitters in the network. Well, so we talk about we now have these programmable switches or programmable devices in the network, right? Is it then possible for us to build heavy hitters directly in these programmable switches? So remember that these switches allow us to do application-specific computation inside the switch data plane, right? And we are able to also maintain certain states in the switch across different packets. So naturally, what we think is that, okay, so because all these packets will flow through this switch anyway, so in the switch, we can program and maintain a flow table directly in the switch data plane. And every time when the packet comes through, we write this data plane program to first parse and recognize the flow ID, for example, the source destination IP pair, and then being able to maintain the count by incrementing the corresponding counters in this in the switch. So that's the really high level overview of how we maintain this heavy hitter detection table in the switches. However, this is not that simple. So these counters we can maintain in the switches are fixed width. That means eventually they will reach a maximum, and then they either overflow or you need to stop there, right? So that's not desirable, right? So the second issue is that we need to forget some of these heavy flows in the past, right? So what we really care is the more recent heavy flows, right? So we need a way to forget these counters in the past, right? So to solve both of these problems, a common approach is what we call interval reset, meaning that we reset all the counters for all the flows after a certain time period. Right, so this works fine, right? So it solves both of these issues. But the problem is that it may lead to missing heavy hitters. Right? And to illustrate this, let me just give you a quick example. So here, let's focus on one single particular switch, right? And we have a bunch of packets going through the switch. So let's assume time flow leftwards, right? So in the first time period, time interval, right? We track the flow count for each flow. And let's say our criteria for reporting a heavy flow is if in an interval, the flow count exists 6 packets, right? So hypothetically, right? So that that threshold can be defined by the administrator, right? So in this case, we can see that in this particular time interval, flow B exceeds the threshold. So we're just going to report it to some network admin saying that, okay, flow B is a heavy flow, right? And we record that. And then, so because it's time interval reset, after the first time interval, we reset all the counters, everything back to 0. And then in the second interval, we can see that none of the flows actually exceed 6 packets, right? So we report no heavy flows. So what's the issue here? So what we really see is that is B the only heavy hitter in this network traffic? So it turns out it is no, right? So if you look at this network flow C, right? Apparently it actually exceeds 6 packets in a particular time interval. The time reset, the interval reset approach is not able to identify that because we actually reset the counters in the middle of that packet stream. Okay, so in that sense, we are actually missing this heavy hitter. So we actually ran some analysis on this. So we took 3 different ISP backbone traces, the CAIDA traces, and we use an idealized interval reset algorithm and try to catch their heavy hitters, compare them to some ground truth. We found that interval reset algorithm is missing from 10 all the way to 20% of the heavy hitters in this ISP traces. So that is a really significant amount of heavy hitters that we are missing using this approach. So that's the first problem, that there are a lot of these heavy hitters being undetected. Now, the second challenge of designing a heavy hitter in programmable switch is that these switches have very limited amount of resources. So when I introduce these programmable switches, I give you the idea that, okay, so you can do arbitrary computation in the switches. But in reality, it is much more limited, right? For them to able to provide line rate processing. So they have this really rigid processing style with very few amount of resources. So for example, there is a fixed number of pipeline stages each packet go through. And the stateful memory, the registers and memory, and they are stage local, so you cannot access these memory for different stages. And also the amount of memory available on a particular switch is quite limited. This is on the order of megabits, instead of like the gigabyte memory available in a high-end server. And also, because each stage can do very limited amount of work, you need to partition your algorithm, your system deployed on these switches across multiple stages. And you need to make sure that it is less than the total number of pipeline stages. And also, the computational units on these switches, they are very limited. So you can only do very primitive arithmetic. Floating point is out of the picture, and you can't even do divisions. At the same time, so these application specific logic are not the only thing running on these switches. So these switches also need to run their regular switch functionalities like L2, L3 switching and routing. So these basic switching functionality also occupy these pipeline stages. So in fact, a reference design called switch.p4 for these programmable switches take more than 10 pipeline stages of the entire 12, and then almost half of the occupied stages are very densely utilized. That means there's very little available resources left for your applications running on these switches. All right, so that really motivates our heavy hitter detection implementation on a programmable switch, what we call D-sketch. So our two main objectives is to first minimize the number of heavy flows going undetected, and also minimize the resource consumption so that it can be easily integrated with other switch functionalities. So to solve the first challenge, which is we want to detect as many heavy hitters as possible, we found that the problem with interval-based algorithm is that you actually reset all the counters after every interval, right? So our insight is that instead we need to keep track of these counters even across time intervals. But how do we actually do that and also be able to forget really old heavy flows? And the key design we have is a time decaying algorithm, right? So the intuition is that we will decay the counts as time passes, and the further away in time when we last increment the counter, we will decay a bit more, right? So overall, it follows an exponential distribution, which is natural for a lot of these streaming applications, right? So, but the problem with time decaying is that these, especially exponential decaying algorithm, rely on floating point operations, but these operations are not available on these programmable switches. So can we approximate this exponential time decay? So the way we do that is we use binary shifting, which is available on these switches, to approximate. Right. So to give you a quick example, so let's say we have this same kind of flows across going through the switch. So we keep track of the number of the flow counts for each flow as before, but we also keep track of the timestamp when the flow was being updated. So in this case, this is in time interval 1. So we keep track that, okay, so these counters are updated in time interval 1. Right? So when we move on to the next time interval, right? So we saw that, okay, now we are in time interval number 2. So now we need to decay the counter for this particular flow. And then we track how much time has elapsed. In this case, 1 time interval. So we just decay the count by shifting by 1 to give you the new count before you increment. So eventually we will see that by using this decaying approach, we saw that flow C got exceed the threshold 6, so that becomes the heavy hitter. And the key point is that this heavy hitter will be missed using a time reset interval reset algorithm, because the previous flow count will be cleared to 0 in that approach, but not in this approach. So the second issue we are having is the limited resources on these switches. So really we cannot keep track of every single flow on this switch because there's the limited memory. Right? So we need to use some approximate data structure to keep track of the flow count. And to do that, in this sketch, we use an approximate data structure called count-min sketch. So count-min sketch is a pretty well-known data structure, a trade-off accuracy with memory requirements. So I'm not going into the details of how it works, but essentially it's just using multiple hash functions, independent hash functions, So every time you want to increment a count, you just increment the count for each individual hash functions. And then when you want to get the count value, so you get all the numbers for the mapped cells, and you get the minimum, right? So sometimes the comment cache may give you overestimate, but you can essentially reduce the memory usage. So in this cache, we augment comment cache with a timestamp in order to implement the time decaying algorithm I just talked about. So instead of just keeping a single counter for each cell in the comment sketch, so we also add this timestamp for each cell. So every time we increment a counter in the comment sketch, we also look at the timestamp when we last update each cell. Right. So with that information, we can know how long the time has elapsed since the last time we updated the counter. So using that information, we can essentially run our decay algorithm, right, using the binary shift to update the counter with the time decayed value. And then lastly, we can update the timestamp in these cells using the current timestamp. So that is the basic overview of how we use comment sketch to implement time decaying algorithm. Right, but for details, please refer to our paper. So we run this sketch on the benchmarks we talked about before, and we saw that we are able to get up to 12% reduction in terms of the missed heavy hitters compared to all the other interval-based algorithms. Right, so we are getting slightly lower performance than the other system called Concur, but the reason is that the other systems is using a sliding window approach. And then the problem with that approach, which I illustrate in this slide, is that that approach requires significantly more resources on the switch. So that's basically you cannot integrate that approach with the basic switching functionalities, for example, switch.p4. While in this cache, we are able to do this heavy hitter detections with minimum resource utilizations on the switch. So actually, we are only using 4 pipeline stages and a very small amount of memory usage, leaving significant resources for the other applications, making it a practical solution. Okay, so I know I'm now having a lot of time left, so I will go a little faster on our second work. So in our second work, DIDA, so we use programmable switches to build a in-network defense architecture against amplified reflection DDoS attacks. So amplified reflection DDoS attacks are pretty common these days. So they are what they do is really to exploit the connectionless protocols like UDP. What they do is that the attacker will spoof the IP address of the target victims, and then they will send, for example, DNS queries to some misconfigured or less secure DNS resolvers with the source address of the victim. So these resolvers will later send DNS records of the attackers. And the point is that because the requests themselves are much smaller than the responses, so the attackers can amplify their attacks by generating this huge amount of responses to the victims to overwhelm their system and to overwhelm their network bandwidth. Right. So in this experiment model, we mostly target an ISP network with a bunch of border routers and access routers to the customer and enterprise network. Right. So customers can still go to public DNS servers to get their to resolve their DNS queries, but the attackers can use spoofed requests to generate these spoofed DNS query responses and send them to the victims to overwhelm the system. So defeating these DDoS attacks are actually very hard. So there are a few factors, and the most important one is that this attack looks exactly the same as benign traffic. So it's really hard to identify. And also, when the victims know they're being attacked, it's already too late, right? Because their network is already being overwhelmed, right? So doing anything on the end host is not really being effective. So you have to collaborate with the service provider, the ISP and the AS. So what we do in DIDA is we leverage these programmable switches to detect and mitigate these amplified reflection DDoS attacks inside the network itself. So our key insight is that the pattern of these AR DDoS attacks is that the victims are getting unsolicited responses from DNS servers. So to identify these attacks, a really easy way is to match the responses to the request of a particular a client and server of DNS. And if you're receiving significantly more responses than the request, it's highly likely that you're under attack. And to do that, we use the programmable switch on the border routers and the access routers in the network. So what we do is we implement these tables, keeping track of the requests and responses. This is similar to the flow count we saw in the DSketch, right? And particularly, we keep track of the number of DNS requests on the access routers facing the victim and the users, and we keep track of the responses on the border routers that is facing the DNS servers. Right? Really example how we identify attack. So when an attacker try to spoof the DNS request and send it to the victim. So when the DNS response goes to the border router, so the border router will increase the response count for that particular flow. In this case, from the resolver A to the victim V. Right? In this case, the response. So the response here, we see that if we get a significant number of responses because of the attack, and the border router see that, okay, so there is a lot of responses for this particular flow. So what we do is that, okay, so this is potentially an attack. So the router will tag a particular tag in this packet saying that, okay, this is from border router 3, and we suspect this is a DNS attack, DDoS attack. And when the packets traverse to the access router, the programmable access router, it checks the flow table. It saw that there is 0 requests for this particular flow. So means the customer has never requested any DNS request to the resolver A. So the access router knows that this is actually an attack. So I should check so this is significantly higher than the number of queries, right? So this is really an attack. So to mitigate this attack, so the access router will send a particular packet to stop the border router from accepting further responses from this resolver. So you generate this packet and forward it to the border router. And then when border router receives this special packet for resolver A, it will build a in-network ACL list to block further requests from A. So that's the basic way how we handle this, how we both detect and mitigate AR DDoS attacks using our DDoS framework. Of course, I'm overlooking a lot of the particular details, but if you're interested, feel free to talk to me offline or look at our papers. Okay, just quick evaluation result. We actually deploy this, and we are able to really first detect and mitigate 99.8% of the attacks. And also the other thing is that we are able to mitigate the attack quite fast. So after a few few seconds, we're able to the victim's throughput is going back to the original maximum, and we are blocking the attack from the border router. Right. Okay. So in today's talk, I briefly introduced the issue of increasing network speed and traffic and how it affects network security system. And I introduced our novel network security solutions by using in-network computation using new generation programmable network devices. And to that end, I talk about two recent research work our group has done. So this sketch, which we built a accurate heavy heater detection on programmable network, programmable switches using time decaying coming sketches, and also DIDA, our in-network detection and mitigation of amplified reflection DDoS attacks. So with that, so that will end my talk. So I don't know if we still have time for Q&A or we should just move on to the next talk.
I think we can do one quick one. So I saw one question on the chat, so I think we'll just take that if you're okay,
Okay,
Jialin.
sure.
Yeah, so it's from Fei Xiang. He's wondering what is the rough ratio of heavy hitter to real DDoS in the testing data, because he says that the heavy hitter per flow sounds more like a UDP video streaming, while in a naive DDoS setting, each source would generate relatively small amount traffic, which probably result in low disk-catch count. If you can see it in the chat,
yes,
it's also there. Yeah.
Yeah, thank you, Fei Xiang. I think this is a really good question. So first of all, for this sketch, we're not particularly using this sketch for DDoS detection or mitigation, right? So this sketch is a general solution that only provides you heavy heater detection. How you use that heavy heater information is for applications depends on the application, right? So it's true that for certain DDoS attacks that you can look at the heavy hitters, right? So those are very possible your heavy hitters. But for some other DDoS attacks that, as you said, that they are potentially not heavy hitters, they are the small flows, but because there are many flows, right? So there are many flows. That's how to do DDoS, right? So in that case, using a heavy hitter is not your best solution, right? But so in general, so I would say that this sketch is not useful for that particular use case. And we use DIDA for, so for instance, our second work, DIDA, for a particular type of DDoS attack. This is the amplified reflection DDoS, right? Okay, so it really is application specific.
Oh, yeah.
Thank you.
Thank you so much, Jialin, and also Fei Xiang for the question. So if you all in the audience have more questions for Jialin, please feel free to contact him. Yeah, if you didn't catch his contact, you can also contact us, cyber@com.nus.edu.sg, and then we will link you up with Jialin. Okay, thank you so much. So now we will move on to our industry talk, which will be by Oleg Lerner from, sorry, let me bring up his bio. So Oleg Lerner, he's a member of the adversarial tactics team at Signia. So he, in this role, he has been delivering offensive security support for organizations. He has more than 7 years offensive and defensive cybersecurity experience, ranging from development of offensive security tools to security research and analysis. So at Signia, Oleg brings his special orientation for the research of security tools and performing infrastructure attack simulations and red team activities to test security, identify vulnerabilities, and support organizations in enhancing the resilience. So before joining Signia, Oleg was a security researcher at CyberArk. So at this point, I would like to pass the floor to Oleg. Please feel free to share your screen and then start your talk.
Okay, thank you, Vivi. I will share my screen in a moment, everybody. So hi, everyone. My name is Oleg Lerner, and I'm super excited to be here today. And today I'm going to talk about what we think is the next step in red team evolution and how offensive security engineering can dramatically change the way we conduct red teaming. So I'm Oleg Lerner. I'm a security consultant and researcher at Signia. In the past 8 years, I held various positions, including red teaming, IT, and security research. In my current role at Signia, I lead the research and engineering within our adversarial tactics team. Here you can see my bio, so you can feel free to reach out by email or Twitter after this talk. And just a quick overview for those who don't know us. Signia is a cybersecurity consulting company owned by Temasek. We are based in Tel Aviv, and we have offices here in Singapore and New York. And we divide our work into reactive and proactive. On the reactive side, we have incident response teams that help our clients to defeat attacks within their networks. On the proactive side, we have adversarial tactics experts and security architects that work with our clients to build their resilience. A bit about our AT team. Our mission in life is to simulate highly tailored attacks, mimicking some of the most advanced threat actors out there. And our AT team is constantly feeds off our IR team, learning what our adversaries are doing and vice versa. We research and develop new tools and techniques that we later instruct our IR teammates how to hunt for. So before we dive into the details of the offensive security engineering model, I want to share with you something we recently realized that totally changed the way we conduct red team. What you see now on the screen is an example of a common attack timeline that pretty much describes many of the attacks that we got to investigate up until about a year ago. So we can see here pretty standard stuff: infiltration via Emotet, Cobalt for persistency, and off-the-shelf tools for domain reconnaissance and compromise. But something changed. In the past year, we see more and more attacks that look like this. Clearly, attacks are becoming more and more sophisticated. We see threat actors using advanced tools, highly customized malware, covered C2 channels that are highly tailored for the environment and can change rapidly. We know that our adversaries are becoming increasingly agile, able to pivot on the fly and modify their modus operandi in just minutes. So we realize that these adversaries are not just highly proficient operators. They have engineered powerful tools and platforms that enable them to be extremely agile and evasive. Now, if we truly want to simulate an advanced threat actor in our engagements, we need to up our game, as we need to stay ahead of the curve. So how do we do that? Internally, we developed an operating model that supports research and development, discovery of new evasion techniques, and attack platform automations. We truly believe that our offensive engineering model, coupled with our knowledge and real-life combat experience, will bring the advantage we need. And today I want to share some of the design principles of this model, as well as its implementation in our adversarial tactics team. So let's talk about some of the design principles that drives that model. We want to be able to simulate various threat actors, from hacktivistas to cybercrime, and even some state-sponsored threat actors. And we need the ability to switch profiles just with a click of a button. Our adversary simulation is mission-driven. We simulate a threat actor that wishes to accomplish something. It can be extract data, deploy ransomware, or even create fake SWIFT transactions. Whatever you can think about that will bring impact to an organization. So we need the ability to create malware and tools that are fit for the purpose. Technologies change and grow, and tools need constant improvement and adaptation. We need the ability to automatically update our toolset across the cyber kill chain. And of course, we want everyone on our team to take part of the engineering process and contribute from their field experience. So now let's deep dive into our model. And our first step in the process is to fit our operating model from our battlefield experience. And basically it comes in two ways. We get to watch adversaries in the wild, National Geographic style. We see new tools and techniques And if we encounter any unfamiliar technique, we learn and adapt. Also, we proactively attack organizations and platforms. So we have to develop new techniques and tools by our own needs. And now let's see an example of that. In the last couple of years, we see more and more organizations transitioning to hybrid environments, including on-prem and cloud. So it makes sense that we see threat actors taking advantage of that transition. One interesting post-exploitation tactic that they use is pivoting from on-prem to cloud environments and then back again to on-prem to escalate their privileges. So what do we learn from this and how we adopt and automate this tactic in our proactive red team engagements? During the IR project where we encountered this, we also got to assess a client environment. And this organization had a hybrid multi-cloud provider environment. And this is a huge attack surface. So during our engagement, we realized how we can leverage the cloud environment to bypass defenses and pivot back to the on-prem infrastructure and fully compromise the estate. Now, this took us quite some time to identify. We realized that there are numerous similar attack vectors, and there were no tools at that time to identify cross-platform attack paths. Even though we had some tools to enumerate cloud environments. For example, we had AWS X to assess AWS environment, but we didn't have no tool to connect the dots between different cloud environments. So we don't have no tool to map, analyze, or discover high impact attack vectors across cloud and hybrid environments. We understand that we need to develop a tool that will automatically map and identify this path traversing from on-prem to cloud environments. So what do? We develop our own tools. And one example of such development is a Security Cloud Scout, a tool that helps us to identify attack paths in hybrid environments between on-prem and cloud infrastructure, including multiple cloud providers. By the way, feel free to download the tool and try it. We would like to hear your comments about it, and feel free to reach us if you have any questions about it. Now we can see a diagram of Cloud Scout architecture. We use a variety of tools to enumerate the relevant environments we work against. And we have tools like Shellhound to ingest the on-prem domain, AWS X to ingest AWS environment, and StormSpotter that ingest Azure. So we use those tools coupled with our own ingestions to combine and create a single map that shows cross-platform attack paths. Also, the tools we just mentioned, they have their own capabilities to map and identify attack paths within the environment they work against. But by using Cloud Scout, we consolidate all the information under one database, which allows us to map and identify cross-environment attack paths in one single tool. Also, I want to mention that later on, SpectreOps developed their Bloodhound tool to support Azure environments. So now they can map attack paths between on-prem and Azure, which is great, but we still see a lot of AWS and GCP environments. So now we can see an example of the identified attack paths using Cloud Scout. We can see on the top example the connections we have between Azure and on-prem. Some of them have connections between each other, marked with red rectangles. Eventually, we can identify an attack path from an on-prem workstation or user, moving to Azure, and pivoting back to on-prem with highest privileges. And the bottom example is a really good demonstration of Cloud Scout, as it showed its unique capabilities to map cross-platform attack paths. We see how we can leverage on-prem credentials to pivot into Azure and then once again into AWS with higher privileges. So during the engagement we had, we targeted the AWS environment. We landed on a workstation which had a user session with privileges over an application in Azure. And that application was assigned with enough privileges to escalate in AWS environment to the root level privileges. Without Cloud Scout, probably it would take us days or even weeks to identify this attack path. But this is just one example of a tool, in particular, an offline one. We use offline tools in our own environments without the need to be evasive, because we use them against the data we already collected from the target network. So in addition to our offline tools like Cloud Scout, we also need to use online tools which will be executed on the target system and needs to be undetected. Those tools are written in different code languages. It may be C, C++, .NET, PowerShell, and much more. So we want those tools to be ready for use with the ability to be evasive against a variety of security products. So how do we do that? Now let's talk about our offensive CI/CD pipeline to understand how we create evasive tools. Advanced adversaries don't just use off-the-shelf tools. They customize, modify, obfuscate, hack in order to tailor them to their target security stack. So how did we implement the CI/CD pipeline internally? Here we can see a common CI/CD pipeline conducted of the following components. We have our source code, which we want to compile. Then we need to test our software. And after the tests were successfully done, we can deploy it to our production environment. But with the basic CI/CD pipeline, our offensive tools will be simply detected by various security products, from antiviruses, EDRs, web proxies. And now let's see how we can leverage the CI/CD pipeline with some must-have capabilities to turn it into offensive security pipeline, which will enable us to create highly evasive malware and tools. So we need to add capabilities on top of the basic CI/CD usage. For example, obfuscation, packing, and sandbox escaping. Each and every component added here will have a variety of techniques ready for use. So we can see that we have a compile phase where we have C++ language supporting C++, supporting C, .NET, and more languages we need. So we can mix and match attacker capabilities in a click of a button. This enables us to simulate various levels of threat actor according to the sophistication level required. Also, will help us to quickly adapt to the situation in the field. And here we have an example of a tool from our community called Rubius and written by SpectreOps. And we can see here the journey that Rubius is taking on our CI/CD pipeline. We have the source code, which is written in .NET. So firstly, we need to compile it. And we use in a Docker instance, we spawn it up in order to compile the tool. And then we use our in-house obfuscation technique. So we spawn another Docker image to obfuscate the compiled tool. And then we have our tool ready to use. Here is another example of our in-house developed tool called Shemo. It's a PowerShell C2 platform that communicates over Google Translate, developed within our team that we might publish later on. And the journey of Shemo on our CI/CD pipeline will be different from the one Rubius took, as we want to simulate another threat actor with different capabilities and techniques. So we use one of our obfuscation techniques coupled with an encryption technique. And in this example, we don't need to compile it as it's written in PowerShell. So here is an example snippet from our actual pipeline, we can see the different steps in the pipeline and our ability to pick and choose evasion techniques to the tools we are building. And the last step in the pipeline is validating that our tools work properly after the chosen evasion techniques were embedded. After successful validation, the tools are deployed to our attack infrastructure, ready to be used by operators in the field. So, okay, now at that point, we have an arsenal of tools written in different languages with various evasion techniques. But yet, it's not enough. We need to validate that our techniques are successfully flies under the radar of various detection systems. And for that mission, we must have an OPSEC labs. We know that our adversaries have OPSEC labs. They use it to test their malware and evade detection, even for the more advanced security tools out there. So if we want to level the playing field, we need to test our tools and malware to ensure that we can simulate threat actors. And tools can be detected either in a static or dynamic ways. We want to make sure we test our tools against the security stacks. Antiviruses, EDRs, proxies, deceptions, UEBA, and the list just goes on and on. So we take the tools created by our offensive CI/CD pipeline and use those as input in our OPSEC labs. What we see now on the screen is an output of Dexter execution against a PowerShell tool called PowerUp. And Dexter is our internal developed detection tool, developed by our IR teams, which helps us to scan suspicious files. So Dexter has capabilities to test and analyze suspicious files against various security products within our labs. For example, we test against Carbon Black, Symantec, Defender ATP, and some more. Also, it has some machine learning predictions that were developed internally. Okay, so at that point, we have the knowledge which versions of our tools will be detected or not by the security products we tackled during engagements. And on the screen, we can see on the left the output of Dexter against PowerUp, which didn't pass our CI/CD pipeline. We can see that it was detected as malware by our OPSWA and machine learning. And on the right, we can see the output of Dexter against the same PowerUp tool, which went through our CI/CD pipeline. And now it was not detected by our OPSWA and drastically dropped the percentage of the machine learning prediction. Now, how do we operationalize our offensive pipeline? We can imagine these processes take time and resources. Setting up and maintaining multiple environments, pipelines, OPSEC labs, and attack servers is a huge task. We must automate if we want to scale up and build a truly advanced threat team that's on the same level, and maybe perhaps even more than some of the best threat actors. So how do we tie it all together? In the end of the day, we need to execute multiple campaigns all over the world in various environments and with different platform and security stacks. It's clear that we need an offensive DevOps capabilities within the team to support it. Will help us to stay cost effective, create and destroy the infrastructure in minutes without the fear of deleting necessary data or infrastructure. So we talked and explained the infrastructure we need for our offensive operating model. But we didn't mention the attack infrastructure we need during an adversary simulation. And here is a basic example of such infrastructure used for red teaming. We have our C2 server, domain fronting, file servers, and scanners. And of course, we have our supporting infrastructure on the left. But in different projects, we have different requirements and objectives. That means our infrastructure will change accordingly. And usually it's tedious, manual, and time-consuming tasks. And another question, what happens when we have more than one project ongoing? We need to multiply our infrastructure. So now let's take a look, closer look into a part of our supporting infrastructure. We can see here a basic diagram of the architecture we use for our password cracking rig. We use the password cracking rig to crack passwords during engagements. So instead of having traditional physical cracking rig in our office or on our own laptops, we use cloud providers to spin up an array of virtual cracking machines that work in parallel on multiple projects. Into our cracking machines, we attach NVIDIA GPUs. We need to install NVIDIA drivers and toolkits for proper and effective function. The driver is called CUDA, and that's why we call our cracking machines that way. So to properly allocate tasks or load balance between the cracking machines, we use HashTopoly server, which manages the whole cracking procedure. We use the infrastructure as code. In our case, it will be Terraform to automatically deploy and configure those instances on our on-prem and cloud environments. And this is an image that illustrates the multiple CUDA instances we have created and attached to our HashTopoly server. We can see the average GPU and CPU utilization, as well as the device temperature. Now, this might seem less exciting compared to other stuff we talked about, but maintaining and operating a cracking rig alongside supporting attacker infrastructure can potentially cost hundreds of thousands of dollars per year. So we need to ensure that we can scale up without dramatically increasing our operating costs. To conclude, we showed how we implemented an operating model for advanced red teaming. We offer today a new model and maybe even a new team structure for red team operations. It is clear to us that we need to have an offensive engineering function or team that will allow us to simulate various threat actors' profiles and create object-driven red team operation tailored to our clients' environments, and gain valuable insights about new attack techniques from our incident response and adversarial tactics team members. We see this as a natural evolution of red teams from small teams focused on finding vulnerabilities and misconfigurations to full-blown, large-scale adversary simulation teams with in-house R&D and engineering capabilities that mimic some of the more advanced threat actors out there. And thank you very much, guys. And if you have questions, I think we have time for 1-2 questions. And if you want to reach me out, you can do it by my Twitter or email, and we'll answer all your questions you have.
Yeah, thank you, Oleg. Yeah, to the audience, if you have questions, we do have time for one at least. Yeah, so please put them in the chat and then we will pick it up. Okay, if there are no questions, thanks once again, Oleg. So yeah, as Oleg said, you can always reach him for a deeper discussion on his presentation. Okay, yeah.
Thank you very much, guys.
Okay, so now we move on to the next agenda, which is the wild and crazy ideas pitches. So these are the pitches from our members who have some cybersecurity project ideas, and they are looking for collaborators to work together on them as projects, which could be supported by our grant, which is launching today and introduced by Prof. Abik earlier. So this of course, then you will need to apply together with the presenter if that is the case. Yeah, so without further ado, we have 3 pitches today. So each of the presenter will have 10 minutes. So we will not have Q&A for each of the pitches, but we do encourage you to contact them for further discussions to understand more of the ideas and see how you can collaborate. If you have quick burning questions, you can still put them on the chat, and then the presenter may go there to respond to you on the chat. So that will be the setup for these coming 3 pitches. Right. So the first pitch that we have is from Jay Prakash. He's the founder of Silence Laboratories, and this is titled "Bringing Seamless Trust and Security to Last Mile Delivery." Jay, please feel free to share your screen and start your pitch.
Thank you very much. Is my screen visible?
Yes, but I think I'm seeing the presenter view, so you may want to share the other screen. Yeah.
How about now? Wait, sorry. Is it fine now?
It is still the presenter screen that, you know,
Okay.
okay, yeah. If you're using 2 screens, maybe it's the other one.
Yeah,
Yeah.
I just shifted.
Yes, it looks
Okay.
good now.
Yeah, thank you.
Okay,
Thank you
please
very
start.
much.
Thank you.
Welcome, everyone. I'm Jay. I'll be presenting one of the ideas that we have been brainstorming some time back. So this is about bringing seamless trust and security to last mile delivery system. So the problem is trust in last mile delivery. Why? Because current systems are largely driven by human trust. They have human in the loop somewhere. What is last mile delivery for a person who might not know or they are not well aware? Last mile delivery is the very last segment in e-commerce where any good which we have ordered online is being delivered from a warehouse located nearby to the address to the person's door. And typically, there are many companies, aggregators who handle these e-commerce last leg and help deliver goods to the door to the person in optimized ways. What's the actual problem? Actual problem comes for non-smartphone applications based orders. So when we order a food from Grab or anything from an online app, Amazon Prime or anything, the person who is going to deliver has our exact address, exact lat and long. So they can just directly come to our address and try to deliver. But if you order online through Lazada or Amazon's web portal, what you have is the person's address. They don't have locations. And that's the catch. There comes the actual problem. Now the delivery guy who wants to deliver to your address does not exactly know where to reach in terms of latitude and longitude. Is that a problem? Yeah, that's a problem because the current solution is based on geofencing from landmark. So what the person has is the address near something or near a mall or near a station. And in that case, what companies have designed is they make a fence around a landmark and then they monitor what's happening with the goods, how the delivery guy is performing. This leads to error in 100 to 500 meters based on the landmarks and based on their triangulation methods and how good their NLP of processing the address is. So what does it lead to? It leads to friendly frauds. And the biggest fraud in that case is fake attempt of delivery. What is that? This is a case where a delivery agent who wants to deliver the goods sometime might feel lazy, or it might be the end of the day and he has just 1 or 2 deliveries left, or the address might be very, very off where the person is currently. In that case, the delivery person makes a comment in their logging portal or their app or on a paper that the customer was not present at the address or there was some issue. they can't contact, or many issues comes up, which they create artificially, and that called fake comment. So what happens then? Then the good goes back to the warehouse and it is reattempted for delivery next day or some other day. So is that a big problem? I mean, yeah, Singapore has pin codes masked up to blocks, so it's not a problem. If you have address, then you can precisely reach up to that block, and you can monitor, because every pin code is matched to some lat long by different agencies. But in developing countries like India, Bangladesh, Indonesia, this problem comes up. And this we are telling based on our experience of talking to different companies around these geographies. In terms of numbers, around 10 to 15% of deliveries witness fake comments or fake attempts by the delivery person. And this alone around the globe leads to loss in billion. Why? Because now the cost adds up. Typically, the cost becomes 2 to 3 times the delivery cost in a true or faithful delivery. And not just that, it also leads to bad indicators in companies' APIs. Plus, the company might approach customer to ask over call or over message. So that also incurs some cost, and that leads overall it leads to a bad experience. And geofencing, which we have been talking about, is not a very trivial or practical solution in this case, because you don't have the address, like I said. And then the second problem is fake proof of delivery. So currently, if I receive an order, being a customer, then the proof that a company gets is purely based on manual trust and obligations. Either I will sign, which might be very random and can be easily copied, or in some cases, like Amazon is trying in some of the places in some countries, that you have to give OTP, which the person will type. And this is very important for high value goods or medical reports because of privacy concerns. So the, the task is that the goods or the item or anything that we have purchased online has to be delivered to the correct person, not to anybody else. And if it has been delivered, there should be a way to verify it. Okay, before solving it or before thinking to go ahead, is it the right time to solve this problem? Turns out it is. Because of COVID, and there has been a recent surge in e-commerce, and it is expected to reach $4.3 trillion by this year. In UK alone, year-on-year growth has been 74% in online retail, and you can see the graph is literally exploding in the past few years, especially last 1.5 years. So this is a very right time to solve this problem, because the larger the market, the more the goods that are coming into the space of last mile delivery, more will the chance of errors. So what Silence Lab is proposing is to build a silent delivery, which is vowed to bring trust in last mile delivery, but without any interaction, with zero effort from a customer or from a delivery guy. So SL proposes a delivery engine which will have potentially 4 blocks. And this has been partially developed already, but it needs much robustness, a bit of research, and then pushing down the pipeline for actual use cases. So it's totally based on the assumption that all the delivery guy will have a smartphone, which will have the sensors, IMU sensors, and access to microphones, access to RF RF modems, etc. So there will be a state monitor, which actually monitors what the delivery guy is doing, whether the delivery guy is in a vehicle and the vehicle is moving or not, or the delivery person has hopped outside the vehicle, walking, taking a stair or something. So it's a constant monitoring of variable that has to be done on the phone, very lightweight, because based on our communications, battery consumption is a very big problem for these people, because one, they use cheap phones. Second, they go on long delivery. So something which is very battery intensive might not work, or they won't be willing to integrate. Second thing is that's why, because the battery and the issues of where to run the algorithm, the whole algorithm should come up or being triggered at the very right time. And that trigger has to be designed. Then a very context-aware sensor fusion will be done. And SL proposes to do infrastructure fingerprinting, both generation and verification. What does this mean? Potentially, apart from other state monitoring and right trigger generation, what it will be exploiting is that the path from the road or the path from the vehicle up to the delivery person's house or the gate is a bit of random if we compare across different geographies. So it has a hot start and a cold start. So one portion will be completely, be working from the first go, and the other portions of the algorithm will run after the second or third deliveries in a similar locality. And it will converge with the second delivery. Because what the engine will be doing, engine will be actually fingerprinting the path based on the turns in the buildings, the possibilities of having a lift, the possibility of having stairs, and different castings in different sensor domains like magnetometers, how how the signals are varying across all these sensors that are present in the phone. And this will be used to first prove that the infrastructure fingerprints can be independent, and which has turned out to be true so far. And then a very lightweight verification will be done. Apart from this, there will be a personalized and non-personalized models which will be built, wherein the habit of one particular delivery person will be learned, plus a very generic model will be built, wherein this information from different sensors will report based on some fusion that the attempt is actually correct or not. And this whole thing will start to run in from the time the person hits that the attempt was made until certain time is in the backward. The whole algorithm will run in back. And this whole 4 blocks will report, okay, if the attempt that we have made or we have been reported to made were done correctly, and if the delivery guy is speaking the truth or not. So basically the aim is to kill or remove human in the loop so that everything runs in the background and we don't expect anything from the customer or from the delivery person itself. And we also intend to research how this whole thing can be integrated on the smartphones, smartwatch, or very low cost earbuds. And these are all parts of research. But the tentative goal is to make SDKs and APIs on very robust algorithms, which can be running on these COTS devices right from the go. And surely it will add multiple values. And one of them is honest attempt of delivery, and others are like, if we have a very right proof of verification, then the tests or the medical reports will be preserved in terms of privacy, and it can also lead to a more robust contactless delivery verification at the end. So the whole experience might look like this. You order this delivery at a time, and the delivery person either hands over the delivery to you or reports that you are not present. And our whole APK suggests the attempt was fake or honest, all while running in the background and with a very high usability from both fronts. And potentially it will save a good amount of cash from the company, because that's totally getting burnt out as of now as we speak. So every increase in the accuracy will be a savior from the last mile delivery burn rate. That is what we are proposing. And we are very open to collaboration from academia and from different industries, from both designing algorithms or making it robust or doing proof of concepts. Thank you very much.
Thank you very much, Jay. So if you are interested in Jay's idea, please do contact him to discuss. So now let's move on to the next pitch from Hari Garg. He's an associate professor at NUS. So his pitch is on BTC Bull. Hari, please feel free to share your screen and start.
Yes, hi, thanks, Dr. Swahindra. Really appreciate this opportunity to be addressing all of you guys. All of you guys are welcome to the BTC Bull. All right, I'm gonna do some screen sharing, but this is a day for wild and crazy ideas. To the extent that I said, I'm gonna maybe have like a little bit of a wild look, so I didn't comb my hair this morning. All right, but that's just for starters. But the thing that I'm going to do here, okay, let me do a screen share first. Maybe in all this excitement, I shouldn't get carried away like that. So I'm going to do screen sharing. There we are. And can somebody confirm that they can see the screen?
Yes, I can see the screen is on your PowerPoint app.
Yeah,
If you intended that, yeah.
Yeah, I'm going to leave it like that because I want to tell you guys upfront that there's only 7 slides that I have. Okay.
Okay.
So, and this one is truly wild and crazy. And I mean it, okay? It's an improbable journey that I want to take you with me, okay? I'm here to sell you something rare, something that does not happen every day perhaps, or maybe it has already happened to you, I don't know. But it's rare, it's improbable, and it's called, I want to sell you the dream for $1 billion. It's a dream, $1 billion dream. All right, let's get started on this journey. Now, when I suggested the topic, it was going to be BTC Bull, but then I checked the BTC. Could we have the person be muted? Okay, thank you. I think that's a part of the the ambiance of being wild and crazy. So that's good. So I checked. I said I'm gonna call it BTC Bull. But then when I checked, the BTC had dropped from 60,000 plus to about 38,000 or something like that. So I said I'm gonna call it BNB. The first B stands for the bull, and the second B stands for the bears. Okay, and this is, I think, taken together, they constitute the journey that I'm about to sort of take you on. All right, start early days. Blockchain, and it's not too early, okay? It's an invention of a lifetime. Trust me on this. It's like a light bulb invented all over again. You look at light bulb, everything was known. The science behind light bulb was known, God knows for how long, maybe since the times of Newton and who else, all right? But the challenge was to take all that science, put it together in a blender, blend it, and what comes out of the blender is light bulb. Same thing with blockchain. You'll think about it, all the methods, all these crazy ideas that computer scientists always have had, those ideas were known. All right, hashing was known, digital signatures were known, proof of work was known for emails, all these cryptographic methods, everything is known. But the idea is you take all these methods, all right, that you know, put them in a blender, and it's not a blender that someone else has invented. It's a blender that you invented, all right? Put it in that blender, and what comes out is a trusted system of computing. All right, it's trusted, it's irrefutable, immutable. So blockchain is a human system of trust, but it's built on the internet. And in this day and age, we cannot separate the internet with who we are. All right, so I believe it's very hard to say where humans end and internet begins, or the other way around. All right, so what I'm here to tell you is basically look at blockchain as an invention, as a concept. So blockchain is a concept. It's an alpha product. It's an amazing product, amazing. So please don't think when I call it alpha or beta, I'm saying it in a bad way. I'm saying it because I am personally a huge admirer of blockchain. It's an incredible thing. The only gripe I have about blockchain is that how come I didn't invent it? Okay, that's the only gripe. Other than that, it's a concept. But then somebody didn't stop at the concept. They went one step further. They created a product called BTC, Bitcoin. And that Bitcoin, the way it stands, to my understanding, is one of the most successful, historically speaking, one of the most successful beta product. What I want to do is look at BTC, all the good things that BTC does, but it also created an opportunity, a market opportunity, because now we have customer feedback. We have all the lessons, right? BTC has been around. A lot of other things have been around. So we have feedback, we have lessons from the markets, the customers, the stakeholders, the researchers, and so on and so forth. Take it all together, all right? And then we bring our own sense of wild and crazy ideas, and we want to create a BTC bull. That's a cryptocurrency. And we want to go. So this is now going beyond BTC. All right. We want to be, we don't want to, I don't want to say I want to compete with BTC. No, we want to learn from BTC. All right. And we want to go further beyond, as Newton said, that he stood on the shoulders of the giants and he could see further and farther. I want to stand on the shoulders in the most admirable way, on the shoulders of BTC. It's an incredible thing. I truly believe it's a wow. All right, it's a wow. It unleashed tremendous value in the marketplace. Tremendous value, folks. Think about it. All right, and that's what we want to do. So we want to go from BTC, right, to BTC the bull. And the journey is, we look at it. I mean, we can talk about, you know, philosophy. So it's a digital leviathan. Okay, understood. Then you say, but truly speaking, it's not a marvel or a gem of technology. It's not. It's a marvel, true marvel of technology, economics, law, politics, human behavior. You name it. It's a real deal. It's a package. It's a wholesome, holistic package. Now, where are the opportunities? Is it done? No, it's not done. It's getting started. All right. So what you see on the bottom are some of the key features. The ones in the red, I believe, open doors for the bull. All right. So whether we talk about the high energy consumption, we talk about the transaction rates and costs, we talk about the volatility in the exchange rates with the fiat currencies, we talk about the animal farm effect, which is the concentration of mining power over time, and so on and so forth. So there is tremendous room. There is tremendous room for us to sort of build on where BTC and all the other alt currencies are. All right. So the room for ideas, and that's this day here, ideas. The room for ideas is kind of like, it's amazing. It's large, it's huge, it's deep, it's wide, you name it. Many have come and many more will come. I'm not saying I want to write the last words. There is no such thing as a last words to human ingenuity and innovation. So I would not be writing the last word. I want to write the next word. Okay? And I need to establish a value proposition. By the way, I'm not telling you how I'm going to solve these energy problems and so on and so forth. That's a part of my secret recipe and sauce. Okay? Sorry, folks, not open for public sort of dialogue at this time. But if you see a sense of passion in my voice, if you believe that I could do it, we have a dialogue. All right? But I got to establish a value proposition for you beyond just cool technology. Remember, BTC is not a technology, right? It's a holistic package. So what I have to do is to go way beyond a cool technology. So it's not about a research project that I'm leading in my lab. It's not about a research project. It's about doing something that will survive and thrive beyond the lab in the real world. All right. And we are talking not just purely technology, a complete ecosystem. All right. So this ecosystem has to deal with economics, has to deal with people, has to deal with media. It's an improbable journey that I want to take you on. Improbable. I'm telling you up front, it's improbable. But then you have to be a bit wild and crazy to imagine $1 billion. Not too many billionaires around, guys. I'm not one either. All right. But I'm telling you, it's an improbable journey. But together, we can make it. All right. Together, we can make it. All right. Keep rolling. So this story of BTC Bull is not about me. It's about you and us. I'm not even a me. I'm a part of a team. The team is here. I'm on the top, Hari Garg. All right. So, and you see certain strengths that I believe I have. Some of my team members, Dr. Rajesh Panikar from NUS, Mr. Lucas Lim, and so on. And these people come with their strengths, and they would complement each other in terms of weaknesses. But what we seek from you, the purpose that I'm here talking to you, is to seek the genius in you, is to shake you up and say, you know, you have a genius inside. Wake up, come, join us. We need people from all spectrums. We need people who live the code. We know people who can turn this dream of $1 into a dream of $1 trillion. All right, we need to manage people. We need marketing. We need finance. We need everybody. All right. So the basic philosophy, and this is my last but one slide, is if you love your money, talk to us. If you love yourself, talk to us. In other words, the bull philosophy is talk to us. All right. The last slide, guys, I may have overrun my time or what, but together BTC Bulls is essentially a story of let's come together and let's create the next true marvel of technology, economics, politics, law, human behavior. It's called BTC Bull. All right. Thank you for your time. I truly appreciate this opportunity to be talking to all of you guys. Wonderful. Absolutely wonderful. Thanks, Dr. Swahendra, for this opportunity.
Thanks so much, Prof. Yeah, so for the rousing call also. So to all of you in the audience, please do contact Prof if you have something to match his passion for the BTC Bull. Okay, let's move on to the next page. So it's from Sanjeev Solanki. He's the team lead at Acronis. So he will be pitching on search on encrypted data and metadata of independent users for smart services. So Sanjeev, please feel free to share your screen and start your pitch.
Sure, thanks, Vivi. Oh yeah, finally. It was very nice talk. The previous one. It was fun to listen. So I'll come back on the tech side. So for Acronis search, Acronis research, from R&D projects, so we do all kind of projects that are linked to data. So just a quick bit about Acronis. Acronis is a dual headquarter company, which is partially Swiss-based and Singapore-based. It was originally founded in Singapore. So the international headquarter is in Singapore, and it exists in globally 33 locations around 150 plus countries. Plus, it has data, local data across 100 plus countries, especially in last year since COVID started. So COVID was a trigger basically to deal with local data governance. And Acronis is slowly moving towards the integrated and autonomous cyber protection. So even though it started with the data protection, now we deal holistically about cyber protection. And one of the common terms that is pretty well understood by all Acronis guys is SAPAS, which typically stands for safety, accessibility, privacy, authenticity, and security. So everything, every solutions, every feature that we talk about, it has to comply with SAPAS. So Acronis, as I mentioned, is converging towards a cyber cloud platform, building up API and SDKs, and it is open to developers who like to try out. So they can go to the site called developer.acronis.com to learn more about it. So this is about because it's about information that isn't backed up, that need to be recovered perhaps in future, and it may be regularly recovered depending on the crashes, or depending on the attacks, depending on various kind of attacks. So information retrieval is a pretty standard technique. So if you look at the mechanism, there are two things. So normally, you as a user, you search for information, and that search typically depends on a certain kind of indexing. If it's NLP based, so it will be something like mentioned here, or it can be a bit more advanced. So I keep the simple stuff. In search, you can do various kind of searches. It could be for fuzzy search, to search, to be simple, like just highlighting and auto suggestions. And based on that, you can, even for backend purpose, you can develop better search strategies. Okay, so across search solutions, typically what we do, and why do we need backup, search for backup data? So one of the key requirements is for restore. And then for smart restore, you basically want to as a user, you want to see that even your node crashed and you don't, if you had terabytes of information, you don't intend to restore all of them in a single go. Perhaps you want to have selective data while the other can be restored back after some time. So you want to have some kind of view, the visual, have some user interface to show. Third could be because of some legal requirements. And typically, if you look at the UI, so the regular search features, I think one of the key features is to be precision. So when you search for something, you get pointed to the most accurate documents, or the files, or the other content that you're looking for, and then standard stuff like completion, highlighting, pagination. And if you go into details, if you are an organization, so as deploy solutions, so you want to look into recovery details, backup and source view. And then you intend that, so if you're using another party service like Electronics, so you want it to be a secure search, that when you are searching for something, when I'm searching for something, it is for me, and not other people are looking for it. And then it has to be a robust search at the same time. What they're in backup. So typically, if you look at the backup and break down into simple chart, it's more like you do the full backup, which is F1, for example, and then it could be just one time full backup and nothing else. You don't do anything for years. Or it could be the full backup and then you incremental backup. So incremental backups could be in terms of additions, and this could be in terms of removal, and the combination of these two over the period of time, which can go into years. And so whatever the information retrieval process you want to perform, it has to be, that should take care of these kind of incremental steps, which are going on. So yeah, so basically when you start with a backup plan, it could be one-off, it could be incremental, and then it could be based on various kind of information coming not from a single point, but from multiple points for a single user. So like I have Office 365, I also use G Suite, I also use a lot of handphones, laptops, desktop, and workstations, so all need to be backed up. So all those are connected. Well, yeah, I think this was from other slides. So typical architecture. Normally we look at is search via slots. Slots is the kind of a patented tech which Krauss guys did in past, which basically is some kind of isolations or split up or compartmentalizations of not just user but even the user data, so that it can be done in a more secure and efficient way, using less resource. I think the closest analogy, not just a kind of analogy, but not really, is more like a microservice. The full text searches are something that everybody looks at. Encrypted archives, I mean, the people are becoming security conscious, and I'm also security conscious, so I want my data to be archived, but I still want all kinds of services that comes with the subscription to any cyber protection solution. And then the deployments, the actual solutions could be on clients. So here's a skeleton view of it is pretty close to what the Kronos use, but not exactly the same. I've I think ripped off a lot of access control, accessibility features that just show the data flow and the task flow. So typically, as a user, when I need to back up, so basically I just trigger I'm a client, the backup client. I trigger the backup client, which stores my files and data, all kind of stuff, maybe my databases and all kind of things into the servers, which could be on-premise backup solution, or it could be a cloud backup solutions on some of the third-party cloud or Tom's cloud. Once that is done, and then there is some kind of task handling service, which knows that when all my data is being stored, it triggers the task for indexing service. And then the task handler is responsible for connecting up all the various components of indexing services and prepare the infrastructure to start indexing the archive. Once it starts indexing, in the meantime, it's also need to understand, because as I mentioned, that Acronis is distributed globally, and they have database centers in 33 languages. So once you back up, so if to build up an accurate or more precise index, you have to understand which language you're dealing with. You're dealing with English, you're dealing with Mandarin, you're dealing with German, or some other languages. So we need that kind of infrastructure at the same time. So index is once indexes are created, they are secured within the slot mechanism, and they can be connected with open source tools like Elasticsearch or Lucene or any other tool. I think we also use custom design tools. So once the indexing operations are complete, the user is I'm ready for the search operation. So typically search for operations, I put up the keyword on the file or some other operations, or just highlight all documents with some specific text. So I submit that, and based on the index infrastructure, it submits request, find the matching indexes, and look at those, compile them together, and find all the list of the documents, the database, and send me back the list in my UI interface. And if I need to open those documents or download or restore, so whatever operation I have to perform, I can start recovering those files. So this is a typical scenario when every party is trusted, the cloud is trusted, everything is trusted. There is no need for encryption of anything. So everything is happening in a plain text scenario. A second scenario could be is for the encrypted archive. So when the user is a bit conscious and they say, okay, my files are important, I want to encrypt them. I don't want any servers or cloud servers, even on-premise services to see it. So I implement, I check box that my information need to be encrypted. So one way to do it is to use the crypto file system, which allow to encrypt your files, and it could be something like, as an example, the GoCrypt FS. So it's a link is here. It's an open source tool which can be used to encrypt, and with a specific user, so he can authenticate and authorize into third-party servers that his files and the information is still indexed, and the indexes are stored in a secure way, so encrypted way. And then when it's needed, so in his view, we still can get information, but there is the file and the indexes are remain in encrypted format most of the time, and perhaps except for certain time when they need to be indexed. So there is an encryption, and information is encrypted, but there is a risk. If you really care about the risk of losing, so there's a window of opportunity, which brings a liability on server side. So if you're using a third-party tool, it is not risk-free. So here comes the research problem statement. So with a similar architecture and with the user data, which could be terabytes, and then the indexing could be gigabyte or hundreds of megabytes. So a secure and privacy-preserving way to enable such searchable feature in encrypted user data, but at the same time, remove the server-side liability. It's typically supposed to serve two purposes. The first one is to deliver results directly to users and not anywhere. So there has to be the tech guarantee in this. And second is to create a secure metadata base. So that too has to be encrypted, which can help the third-party providers like us to create these smart services or leverage on that to create smart services for other customers. The threat model requires that privacy guarantee of data as well as metadata during search, service, process, or activity needs to be guaranteed. Preferably, the solution need to be hardware agnostic, unless it serves some kind of performance optimization. So if we use hardware-dependent solutions, it's expected. If it can be demonstrated with open source tool, I think it will be greatly welcome. And if the solution hits some kind of open source license, I think that will be amazingly and greatly welcome. So with that, I stop. I know the time limitation, so I stop here. Any question should I perhaps can be asked in the future? Thank you very much for listening. Thank you, Vivi.
Thank you very much, Sanjeev. So that concludes for the pitches. So again, you can contact the presenters for discussion further on their ideas. All this, we also have the summary that will be sent out together with the SIG grant call package, so you can look out for it. It will contain the contact details as well as a brief description of the ideas as well. Right. Okay. So now I do apologize for going behind schedule a little bit, but now we arrive at the last item on on the agenda, and thank you very much for staying with us until now. So now we will be launching our SIG grant call 2021 with a briefing. So I will share my screen. Okay. I believe you all can see my screen now. Yeah. Okay. So before I begin, just want to make a quick note that all the information about this SIG grant call will be in the package that we will send out by email after the event. So there's no need to worry about taking down the details of the dates and all this from this presentation. We will send this to the members who are eligible for the call. Right, so as Prof. Habib has mentioned, introduced about the SIG grant call. So basically the objectives is to address gaps in our current cybersecurity landscape, especially in Singapore, with possible application to beyond Singapore, of course. And we would like to strengthen the cybersecurity capabilities in Singapore against not just the present, but future threats. And this we would like to leverage the collaborative effort of the different sectors in the consortium, because this is one of the main driver of why the consortium is formed and why the SIG grant will be awarded. Now for the eligibility, you will need two parties to apply together for the SIG grant. So the project will be hosted at the IHL in Institute for Higher Learnings, or the RI, Research Institute. Then you will need also an industry partner, which is among our member companies. So if any of you are from companies who are not yet a member, we do have a 2 weeks period for you to consider applying and then get the membership approved, and then you can still be eligible for this round's grant call. Then for public agencies, the public agencies can be collaborators of the projects. The grant is not applicable to public agencies, but they can be self-funded and participate as collaborators. These are optional, so the application can have or not have public agency collaborators. And of course, there can be other collaborators, companies, even overseas. There is no restriction on collaborators if the collaborators are not receiving any funding from the grant. So this can be if they are providing you specific data or providing you specific use case or trials, they can be collaborator without having to perform work on the actual project and without getting any funding from the grant. So for each of the institute that is involved in the SIG grant application, then there should be one representative from each institute, which will be the PI or the co-PI. And for the IHL side, the host, we do accept postdoctorate researchers as the main PI, the lead PI. Of course, the postdoc PI must get the appropriate support from his institute to participate in the grant call. So you need to settle issues with your current grant if that is applicable. And then I just mention here that if there is any case where you think the IHL and RI would like to work with public agency without involving any company for a very specific government use case, we don't usually encourage this, but then you can also contact us to check about the particular use case, and the application will only be considered with very strong justifications. In terms of the scope of the project, so this is actually similar to all the past SIG grant that we have given out. So it's to develop technical solutions or study non-trivial issues or explore the new ideas. So there can be cases where you have very specific problem statements. So for example, one of the pictures earlier from Acronis, there's already a very specific problem statement. So you're going to develop technical solutions to address that particular problems. Of course, the application should not be too narrow because we still want to have some worthy ideas to support with the grant. Or on the second case, you can also be looking at very new problems that are not yet sufficiently studied. So this can also be a springboard for you to start studying those problems. If it's complex, you may not have very mature preliminary results to bring you for very mature grants, but then you can use this seed grant as a starting point to develop something to show the prospect of that idea. So this is the idea behind these two different categories. In terms of the goal of the project, then you can aim for deployment in the companies or public agencies. If you have a public agency collaborators, you can aim for commercialization, and also in terms of the later type where you are exploring new ideas, this can lead to larger projects that is under the NCR, National Cybersecurity R&D program. So again, this will be the case where the seed grant is used as a springboard. You still need to have a very clear view on what is this long-term goal that can lead to eventual deployment, eventual commercialization. It's just that maybe this seed grant, you can scope it appropriately to finish it within the 1 year scope, and then you can bring it further after that. The TRL, as before, is from 4 to 8. So you can start with a new idea and bring it to 4, which is prototype, or you can have already prototypes and then you can mature it further until it's almost ready for commercialization or deployment. For the research teams that we are looking at, if you have been a member of our community, I think you have been participating in the special interest group. So this is basically the kind of themes that we have been discussing, and we encourage ideas in these domains, but it is not, of course, restricted to this. There can be, I think here I have put others, which is innovative technologies that may be very new, so we don't have the critical mass to form groups yet, but then it is, if it's interesting, then we can always consider the project to be awarded. I will mention here, just as the pitches that has been given earlier, we also have topics that we have solicited earlier from people who are looking for partners to apply for the grant. So this we will send out with the grant call info package after the event. And again, this is just from the people who have specified that they are openly looking for partners. So you are of course free to also form your partnership outside these send out topics. So for funding scope, the funding period I should highlight is up to 12 months. If you've been with us, I think in the past years we can do up to 18 months, but this year specifically, it's until 12 months only to align with our current funding. So, and because of that alignment, it's quite unlikely that we can allow extension of the project. So please do take note when you are drafting your project and planning for the time period. The quantum is, as before, is up to 150K on reimbursement basis. This is for the direct costs, so it excludes the overhead amounts. So overheads, okay, it's not here, but yeah, overheads will be applicable to the IHL or RI. I think this is a standard procedure that you all know. So, but for companies, it's not applicable. Non-IHL and RI, there will not be overheads applicable. In terms of funding rate, it's up to 100% of qualifying costs. There will be a guide on the qualifying cost that is in the grant call package. For companies, this will be capped at 99,999, basically below 100K. Yeah, I mentioned earlier the overheads, which is 20% of qualifying direct costs for IHLRI only. This is also the standard amount. Now for the industry contribution, we do require cash or in-kind contribution of minimum 30K. So this is the same as before from each partner company. So if you're involving 2 companies, then it should be each 30K. So this is actually a basic requirement for the companies. And again, we have secured the support from National Cybersecurity R&D Lab, NCL, and iTrust Laboratories to support experimentation and validation. They do have their own charging structure for the costs that may be incurred if you want to use the facilities in the lab. depending on your usage. So we will also include all this information in the package, so you can check it out, and it will need to be budgeted into the proposal. Important dates. So submission will open today, right after we do this briefing, and then you will have 7 weeks to prepare and submit, which it will close on 15 July 2021 on 5 p.m. And then of course, you will need to give us some time to do our evaluation, and then by week 1 or 2 of September 2021, you can expect to receive some notification whether we would like you to present your proposal to the evaluation panel. So as in, if there is any eligibility issue, we may also contact you before this. If we can settle it for you, then we will try to settle it before it enters the evaluation stage. If there is, the more of the administrative eligibility issues. And then notification is expected by 7th of October, and the award by 1 week after that. You may need, if for successful applicants, we may contact you to do any revisions required to the proposal. So maybe just some administrative issues, or it could be certain deliverables in the proposal that we may have certain requests. So this we will give about 7 days for you to tidy it up and then submit the final one before the grant is officially sent out to the institution. And then the project is expected to start in November or December. So usually in the when we award the project, then we will specify a start date, and it can be subject to some discussion if you would like to start earlier or a bit later. But this round, I again need to stress that because of the tight timeline of the funding, we will try not to give extensions. So the evaluation is a one-stage selection process. So when you submit, it's already the full proposal. So then the evaluation criteria is given here and also in the document that we will send out later. Basically, is how significant is the problem, how good is the quality of your plans, how feasible it is, and I think probably I will also highlight, if you have the industry, then we would like also some clarity on what is the role of the industry partner. So is it providing use cases? Is it providing expertise in any specific way? So this will really help us, help the evaluators visualize what is actually the value of the project, how it will be actually making impact on the market and on the society. Right. So in terms of the prerequisite for award, so something that applicants should be aware of is the IP. I think I get these questions a lot. So the consortium, we are not owning any IP from this project. So, and neither will the grantor, which is in this case is NCR. The ownership is up to the host institution and the partner companies. And if you have partner IHLs, RIs, for you to come to an agreement about. So you can use like inventorship or the usual negotiations about that. However, the requirement here is that if the partner company wish to have joint ownership of the results of the project, then we will look at the contribution that is given by the company. This need to be in cash for at least 30% of the grant amount that is being requested. Meanwhile, one step below will be the exclusive licensing. So if the company do not wish to jointly own, but would like some exclusive licensing, then we would like for the company to have in-kind contribution, again, at least 30% of the grant amount. So this is basically the guideline that applies to all the SIG grant that will be given out in this round. So on our part, which is the grantor and the consortium, we would like you to maintain the documentation of project IP, because we want to track the outcomes of the project resulting from the grant. And if you are later on exploiting the outcome in some way, commercializing it, and then have our particular deployment use cases in agencies or even beyond, then we would like to know so that we can also evaluate the impact of the project that has been supported by the grant. In terms of review and monitoring, so the proposals should include at least 6 monthly milestones. This is just a 1-year project, so there'll be just at least 2. Of course, if you want to do quarterly, that is also welcome. There'll be progress reports and budget claims that determine intervals. So all this will be actually finalized during the award itself. Generally, for the current practice, the claims will be quarterly. So you do have to be prepared for that in terms of the admin support that you may need. Progress reports will be half yearly. So this is the current practice, but it may also evolve as we also follow the terms and conditions to the latest one. And then the final report will be required within 2 months of the end date of the project. The submission will be online, so the link is here and will also be in the document again. So now the required documents, we will provide all the templates, so please follow the templates to submit. One is the full proposal, so please do include all the information that you would like to be included in the evaluation. If there's any confidential material but is helpful to show the merit of the proposal, then you should include it, but then mark it so that we do not include it in any public release. For example, if the project is awarded, then we may have some press release on the details of the project. So we will certainly exclude any confidential material. Secondly is the budget form. So we will have a Excel sheet with a project budget, what is requested from the grant, then details also for the industry contribution, if it's in kind or if it's cash, what are they going to be utilized for? So all this need to be set out clearly in the budget form. And then lastly is the quad chart. So it's a snapshot of the key information that it can be words or it can be some figures that are representative from your proposal. So all these 3 you should attach with your application on the portal. Right, so that is basically the key information from the grant call. So you can contact us if you have further queries, and also again, if you have ideas that if you need help finding partners with, then we also happy to help you. I think we did a call earlier, so those we have received some. So you need not need to write to us again. But if you still have more ideas after this, then you can still write into us. All right, so that is all. I will stay on for a while if you have questions, but otherwise, I think if you don't have further questions, then we will be concluding this event. Yeah, so thank you once again to all of our speakers, to all of the audience for the participation and for your questions. So then you do look out for the information that will be sent out after this. Again, we will send out to members. So if you are new or if you're joining us as a member of the public, but you are interested to participate in the SIG grant call, then do contact us because you may not receive it by default. Right, okay. Okay, so Prof. Avik, do you have anything to add?
No, I don't have anything to add. It's just a wrap up. So thank you, everyone. Thanks for all your engagement in all these years, in particular through fairly difficult times during the time of this pandemic. So honestly, we are indeed very heartened to have this engagement. We understand this is not easy, and it is very nice that we have this continued engagement and the relationship that we have built up. This continues, and we can continue to discuss and try to improve, as we said, the state of the practice in cybersecurity in Singapore. So whatever small effort we can. So thanks a lot, and we look forward to your proposals.
Thank you, everyone. So I'll still be here. If you have questions, you can just speak up.
One question, maybe.
Yes, Sanjeev.
On one of the deadlines, you mentioned that at the time, 5 p.m. sharp. Why is that?
Yes.
Why not 6 p.m. or the midnight?
I mean, yeah, we can always, I mean, we just need to set one date, right? As in, will you have issue with 5 p.m. in particular? Yeah.
So what if you're meeting and I forget and I want to submit at 5:01 p.m.?
Then probably please do plan ahead and submit it the day before, maybe. Yeah.
Okay, just kidding,
Yeah.
No.
Yeah. Oh, this is Singapore time, so not anywhere on Earth time. Yeah.
Thanks, Vivi.
Yeah, no problem, Sanjeev.